And I'm live for, I think, one person in attendance or something like that. Yes. Okay. Now, as I mentioned to the class here, just a couple of reminders. There are things due on Google Classroom. Please do not forget them. Please do not wait for the last minute. It would not be in your best interest to wait for the last minute. Please don't do that. Progress reports, of course, are due tomorrow. Progress reports are one thing. The end of the marking period is another. Obviously, if you don't get something in for progress reports, it won't hurt you in the long run, but it will if you don't get it in for the marking period. We'll deal with that. Question, do you guys like the grading change where now it's like, what is it to pass a 65? Do you know what I'm saying? Is that better or worse? No, don't say it. Yeah. Yeah. It's really weird. I taught in school once in Maryland. To pass, it was a 60, which basically 59.5 was passing. That kind of blows my mind a little bit. Because, like, I don't know, I grew up in the system that you guys used to be in, where it's like 93 was an A or something like whatever. I'm just reminiscing. Cool. Now, the goal for today. I want to do a little demonstration on Desmos. I love Desmos. I once tweeted back and forth with the guy who designed Desmos. It was pretty cool because I was trying to figure out how he determined. It has this program on here with like a little green balls that drop. I don't know if you guys have ever done that on Desmos. Oh yeah, nice. But like I tweeted at him and I'm just like, asking about how does he determine the random assimilation of these balls dropping and stuff like that. And he gave me some cool information, but I digress. I want to use Desmos for what we're doing today. So I'm going to go over to my computer. Now, for those of you in the chat, hopefully you can see what I'm doing. Yes, there's a little ball of light, but you should be able to see all of the formulas that I put right here. And you should be able to see, for the most part, stuff that is on the middle of the screen right there. So we'll see how this goes. But for now, let's just see what we get. Come here, you. There we go. So I'm going to put in a general quadratic equation. And when I say general quadratic equation, what I'm really referring to, come on, you. There we go. What I'm really referring, what? You need the symbol. Oh, nobody told me. I put in 2 equal signs. What are you talking about putting in 2 equal signs? Goodness gracious. Chapow. I'll move these around a little bit. There we go. Let me show you what I got. Desmos can do way more than you think it can. Now, what's really cool about Desmos is I typed in this generic quadratic, the quadratic equation, so to speak, y equals ax squared plus bx plus c. But then what Desmos allows me to do is it allows me to add what they call a slider for the values of a, b, and c. And right now, can you tell me what values are assigned to A, B, and C right now, according to those sliders? Slider right there, and there, and there. Yay, we did it. Good job. Now, what that really is, if I could write this on the board, this equation in red, this red quadratic that you can all see, is the equation y equals 1x squared plus 1x plus 1. No big deal there. It's just some basic quadratic. If I said solve the quadratic, this brings us back to last week. If I'm looking to solve a quadratic, I am looking for the solutions of a quadratic. I am looking for the roots of a quadratic. I am looking for the zeros of the quadratic. I'm looking for something very particular on this quadratic. What am I looking for on this quadratic if I'm asking to say solve this? There were 4 terms. There was like solution, there was roots, there were zeros, and there was one more. What do you remember? I hear the crickets. I stepped on a cricket the other day. It was gross. What's the 4th thing? What am I looking for? What am I actually solving for? Ooh. One particular place that the quadratic crosses. The x-intercepts. Yes, that is key. If you are looking to solve a quadratic, you are looking for the x-intercepts. So I'm looking at this quadratic right now, just this quadratic. Answer honestly, where does it cross the x-axis? Visually, can you tell me where it crosses the x-axis? Everyone's afraid because they don't want to be wrong. Which one's the x-axis? I can hear the internet buzzing. Apparently it's faster and newer. Literally, which axis is the x-axis? Left and right or up and down? It's the left and right one. Where does it cross the x-axis? It doesn't. It doesn't. This quadratic has what we call, and I'm going to be very clear with my wording, no real solution. It has no real solution. It doesn't have an x-intercept. Yes, I agree wholeheartedly. It was like pulling teeth. Speaking of which, did I tell you about my kid's shark teeth? No, I didn't tell you that. Cool. He has all his teeth, right? He's 6 years old. His bottom 2 teeth in the middle were loose, and they were like loose and loose. They were loose since July. If you ever seen a loose tooth, they were like really creepy. But because they were so loose, his adult teeth started growing in behind them. So creepy. Anyway. Oh, Miss Marie, have him eat an apple. He eats like 3 apples a day. Come on. Anyway, to this. Now, this thing has no x-intercepts, but let me show you what the slider does. Watch what the slider does. This is really cool. Look at that. Look at that thing slide. Hey, looky right here. Looky right here. What if I kept it right there? Now, all of a sudden, this quadratic has 2 solutions. This quadratic has 2 solutions. In fact, look at this. Look. A is 1, B is 1. I kept those the same. And now C is -2. This is y equals 1x squared plus 1x minus 2. It has 2 solutions. Just because I changed the C value, you could factor this. In fact, A times C is -2. What 2 magic numbers work there? What 2 magic numbers multiply to -2, but add up to that B value in the middle? Okay. No, you had it. -1 and +2. Yeah, it works because they add up to +1. You know, T-chart, blah, 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 x minus 1, x plus 2. I'd get an answer of +1, and I'd get an answer of -2, which if I went back to Desmos real quick, watch this sucker. If I went back to Desmos real quick, click, click, you can see it right there. The 2 x-intercepts. Just because I changed the C value. Just because I changed the C value. Hey, go back to geometry real quick in your minds. After you're done crying, think about geometry and think about transformations. Do you remember transformations? You blocked it out? Okay. What's it called when I literally take that image of a quadratic, change the C value, and it just literally drags down like that? Do you remember what that's called in geometry? I didn't teach you this, but I know you learned it. The informal word is called a slide. It's like literally you just slide the thing down, but it doesn't change like the shape or the tenor of everything. But do you remember the actual technical term in geometry? I don't know who taught you geometry. I don't care. I haven't taught geometry in like 11 years. It's called the translation. Some of you are like, yeah. Some of you are like, no, my God. Do you remember that? Translation. Yeah. Now check this out. I'll move stuff around again. I love this thing. I love this program. This program is amazing. Look at this. I'm going to put this back at +1 real quick. Now check this out. I'm going to change the A value. What? Look at the A value. Look. Look at the A value. I'm sliding it, sliding it, sliding it. Oh, come on, you. Let me go the other way. Whoa, what the heck just happened? What the heck just happened to my quadratic? It's another geometry term. Do you remember? A reflection, kind of, you know? It's not exactly a reflection. If I wanted to make it an actual reflection, I would change this to a -1, and I would change this to a -1 as well. And now that would be a pure reflection. But for the most part, yeah, if I change that A value, look what this thing does. It's so crazy. You know something crazy? Check this out. There's a play button. I can make it do it itself. It's so cool. Look at the change of that A value as it goes from -10 to +10 and back again. Wait a minute. What happens? What happens right there? Look at the A value that I chose. Why did it do that? Obviously, if the A value was positive, you'd have a quadratic opening up. If you had an A value that was negative, you'd have a quadratic opening down. What happens if you have an A value of 0? No, the A is 0. There we go. It's like 1x plus 1. There we go. Because I have the 1 and the 1. What happens to the x squared when it's multiplied by 0? Right? But then the x squared goes away. If the x squared goes away, it's no longer a quadratic. What is it? It's a line. In order to have a quadratic, your A value can't be 0. Your A value can't be 0. Check this out. I'm going to do a few more examples on this. I love this thing so much because it shows you a lot of different things. To solve a quadratic, it depends on all 3 values. It depends on all 3 values of A, B, and C. Watch, let me change B. Look at B. Just sliding B back and forth. Look at that. This is what happens when you change that B value. Sometimes you will get a B value that forces an answer. Sometimes you don't. Like right here, boom, there's 2 answers. 2 x-intercepts. None, 2 answers. None, 2 answers. It depends on if it actually crosses the x-axis. This is my favorite thing in the world. Check this out. Hold on. You can make all 3 go at the same time if you wanted to. Look at this thing. It's just so messed up. But you can do that because that's what math does. Oh, fun stuff. Let me put it all back. All right. Make this a 2. Make this a -1. And make this -6. There we go. So now I just forced an equation. I just forced the equation y equals 2x squared minus 1x minus 6. Now that actually is factorable. I'm just going to briefly go over the Tucker method here. 2 magic numbers should be -4 and 3. T-chart, -4 and 3, 2x and 2x. Simplify. X minus 2, 2x plus 3, which gets me 2 answers, +2 and -1.5. And if I go back to Desmos, oh no, if I go back to Desmos, you can see them sitting pretty right there at -1.5 and +2. But that's not the point that I wanted to show you. The point that I wanted to show you is introducing the next step in this process. And I'm going to put it directly in Desmos. Oh no, I did it again. Watch this. Look at that. Look at this. Now this may or may not be familiar to you all. This may or may not ring a bell with Algebra 1. This calculation of b squared minus 4ac. Now the beauty of Desmos is that this b squared minus 4ac is based solely on this a value, this b value, and this c value. B squared would be +1 minus 4 times 2 times -6. 4 times 2 is 8. 8 times -6 is -48. 1 minus -48 would give you 49. What's so special about 49? Why is 49 a special number? Let me show you a different one. Think about that number 49 for a moment. Think about it. And I'm going to put up a different quadratic. Hold on. I'm going to put up a different quadratic. And when I put up this different quadratic, that value of 49 is going to change. Let me do this. 1, 1, and negative 6. Here's a different quadratic. A different quadratic. This is the quadratic y equals x squared plus x minus 6. This time I got a 25. What's so special about 25? Ooh, something special about 25. Let me show you a different one. Let me show you a different one. Let's try 4, 0, and negative 9. This is the quadratic y equals 4x squared minus 9. What's so special about this number that I'm pointing at? First, we got a 49. Then we got a 25. Then we got a 144. What's so special about those three numbers? Ooh. Technically, you can take the square root of them. The official designation would be they would be perfect squares. But yeah, I know we're on the same wavelength, though. All three of those numbers are perfect squares. And you can factor this. You can actually factor this into 2x minus 3 and 2x plus 3 if you went through that Tucker method. And it gets you a nice looking answer. Now, you're not always going to get a nice looking answer. You're not always going to get a nice looking answer. Let me go back to one more example. I need you to pay attention to this one. Here we go. Let me go back to this one right here. Now, check this out. I'm going to slide. I am going to translate the function by changing the C value. Now, right now, this thing, the quadratic that I put up, was factorable. It's factorable, and it has two nice-looking answers at +2 and -3. But watch what happens when I change the C value. Watch what happens when I slide it upward. Sliding it upward, sliding it upward. Look at that number that I put the arrows around. Is it a perfect square anymore? Nope. But you still have two answers. Look at it. What's happening to it the more I slide it upward? What's happening to the b squared minus 4ac? What's happening to that value? Definitely getting smaller. Boom. Now what type of number is this? The b squared minus 4ac. It, 5.8. Don't pay attention to the 5.8. Where's the number on the number line? It's negative. It's negative. How many solutions does this thing have? How many x-intercepts does it have? It has none. It doesn't have any x-intercepts. Check this out. I'm about to do some sliding mechanism here. It's going to be great. Check this junk out. I'm just going to do the b value. I'm just going to do the b value. Just the b value because I know it would do this. Positives, negatives. Positives, negatives. Oh, man. This b squared minus 4ac has a special designation. It's actually known as the discriminant. And it does allow you to understand something fundamental about a quadratic and the number of solutions that it has. It is absolutely wonderful. I love this thing so much. Ladies and gentlemen, if you would, because I know a bunch of you already do, if you do not already have those notebooks out, I'm going to need them out and open. By the way, for the sake of argument, while you're getting them out, I want to show you something. Yeah, leave that. let's see. What are they called? Like ruler. No, oh, that is marble slide. I don't know if you've ever done stuff like this. Oh, there we go. Parabolas. But it's like a marble slide is like something like this, where the ball kind of drops and it's got to go down like that. If you've ever done stuff like that, it's pretty fun. I like it. And then they get a bit more complex where it's just like, yeah, you do have this, but you got to change the thing, you know? So let me change this to like, I don't know, a negative. And then, oh, look at that. Now it works. You know, it's just something stupid like that. I love marble slides. If I had you 2 or 3 days a week in class for 82 minutes, we'd be able to spend like a ton of time doing like marble slides. Stupid COVID. Anyway, back to this. Let's see what we got here. Today, I'm going to be showing you. I'll erase that thing in a minute. Hold on. Where'd my marker go? There it is. We are going to be solving quadratics by quad formula. And today is the 6th. Anybody the type of person in the room where if I left it just like that, would that really annoy them the rest of the class period? It would? No, I'll get rid of it. I'll get rid of it. It's fine. There. It's done. It's gone forever. We'll never see it again. See? Anyway. All right, back to this. Let's see here. Marker, marker, marker. Here we go. First, not the formula, but the equation. The equation is ax squared plus bx plus c. I'm going to set it equal to 0. That is the equation, the general standard form of a quadratic equation where you can correctly identify the values of a, b, and c. Then there is this calculation of something called the discriminant. The discriminant. I'm going to abbreviate discriminant to DISC, disc, in the next set of notes, just because like I don't feel like writing out the word discriminant every time. But the discriminant is the calculation of b squared minus 4ac, just like you saw in Desmos. Now that b squared minus 4ac has huge consequences. Huge consequences. If the discriminant were greater than 0, meaning it were a positive number. If the discriminant calculates to become a positive number, then you would have 2 real solutions. Now I want to emphasize the word real. I really want to emphasize the word real. We'll get into those details in a little bit. If the discriminant were equal to 0, which is possible, I'm going to show you that in Desmos in a little bit. If the discriminant were equal to 0, then you'd have 1 real solution. I'm going to show you a visual of that in a little bit. And finally, if your discriminant were less than 0, we talked about this several times over, then you would have no real solutions. Now, we're not going to get into this discussion today. We're not going to get into this discussion today, but next week we'll go into way more detail. If a number is not real, if a number is not designated to be what they call in the real numbers, how would you designate, what would you call a number that was, quote, not real? Don't use the word fake. Have you ever been taught what a non-real number is? Ooh. Have you ever heard of complex numbers? A couple people nodding. What about imaginary numbers? No? Yes? Do you know what an imaginary number is? It's been a while. It's been a minute, right? Yeah, it's been a minute. Now, I'm going to be focusing on imaginary numbers next week. We have to. For now, if you have a discriminant that is negative, yeah, you'll have no real solutions. Next week, that will still be true. You will still have no real solutions, but you will have two, what they call complex solutions. We'll get into those details. It'd be great. Let me show you an example of one. Oh, let me ask you, visually, what would it look like? What would a parabola look like that only had one solution, that only had one zero, that only had one x-intercept? What would a parabola physically look like if it only had one x-intercept? No, it wouldn't be a parabola. Say again? What do you mean short on one? Oh, I see what you're saying. Hold on. Let me draw what I think you're saying. What I think you're saying is like, it would look like that. It would have to keep going, though. It would have to keep going, and it would still have two. What he just said. Let me show you an example. What he said was, for those in the chat, he said, wouldn't the bottom, or it could be the top of the things facing down, would the bottom just be on the x-axis? Let's check this out. Flip. Oh, I got rid of Desmos. Hold on. Desmos, graphing calculator. Y equals ax squared plus b, bx plus c. Desmos likes it if you sing to it, just so you know. B squared minus 4ac. Cool. So let's see here. I'll make this -6, and I'll make this +9. There we go. Oh, I tripped. That was great. Good thing they didn't see that on camera. Anyway, whatever. I made this a 1x squared minus 6x plus 9. I'll show you what that looks like in a minute, but look at the value of b squared minus 4ac. It's equal to 0. And it is exactly as he just described it. If you were to actually try to solve this by hand using factoring, it'd be y equals x squared minus 6x plus 9. A times c is 9. Can you give me two numbers that multiply to 9, but add up to -6? Yeah, right? And then it'd be like x minus 3, x minus 3, which produce answers of 3 and 3. It gives me the same answer twice, meaning one real solution. Meaning it only touches the x-axis once. I saw what you were saying about a line. Yes, all lines, with the exception of horizontal lines, all lines will have one x-intercept. Horizontal lines might never touch it or always touch it if it's like right on top, you know? Even vertical lines will literally boop, hit it once. Oh, parabolas. No. So back to this. Click. Now it's time. Now it's time to remind you of what you've had nightmares about for a few years. It's time for the quad formula. Quad formula. Quad formula, and I'm going to be very deliberate with how I write this down, is x equals a big old fraction, where on the top is a -b. I say the words plus or minus, but look how they're written. Plus or minus indicates that this calculation can be done with both adding and subtracting, meaning you get two different answers. A big old square root. Inside of that square root, something that should look very familiar. And on the bottom of that square root, a 2a. Now, I'm not always going to put stars in my notes, but when I do, a star is a big deal. Have you ever met somebody who like overuses an exclamation point in a text message? You know what I'm talking about? My wife is one of those people. Disgusting. But anyway, I don't overuse stars. Literally, by the time December rolls around, you'll be able to count the number of stars I put in my notes on one hand. Guaranteed. Here's a star. If you cannot solve by factoring, which is what we've been doing the entire time, the quad formula will always work. If you cannot solve by factoring, the quad formula will always work. The reason it doesn't even matter what numbers are going into it, even if there are no real solutions, you can still use the quad formula to prove that. And I'm going to show you how we do that today. I need you to go back in time in your minds. I need you to go back to elementary school, probably like late elementary school or some junk like that. When you were learning math in elementary school, like my kid right now was learning like addition, like 2-digit addition and stuff like that, I think, in like first grade. Like 11 plus 9 and like 8 plus 5, stuff that it equals 2 digits and junk like that. That's what he's doing right now. But late elementary school, you've gone through multiplication, you've gone through division, you may have gone through a few other things as well. There's a few things in math that you're not allowed to do. Think back to elementary school. What's something in math that they told you can't do this? You're not allowed to do this. If you tried to do this, the calculator would just say like error or some junk like that. What's something in math you're not allowed to do? I have two things in my head. What's a basic calculation where if you tried to type it into the graphing calculator, it would stop you and say error? If you tried to do what? Ooh.
Divide by 0?
Yeah, that's one way. That's definitely one way. In fact, the only way you would divide by 0 in this equation is if your a value was 0. But as I showed you, if your a value was 0, you don't have a quadratic. If your a value was 0, you have a line, which defeats the purpose. Your a value can't be 0, thus, you're never going to divide by 0. What's another thing, the second thing I'm thinking of, that you are not allowed to do in mathematics? It's a little bit more advanced. Hey, what's the square root of 49? What's the square root of 25? What's the square root of 144? It's 12. You should know your perfect squares up there like 20. Yeah. Not joking. But you can take all those square roots. Great. What's the square root of -4? All of a sudden, y'all are quiet. If I just said the square root of 4, you would say 2, correct? Simple. Why is the square root of -4 not so easy? Ooh, let's go back a little bit. I asked you, what's the square root of 49? And you told me 7. Why? Why is the square root of 49 7? Exactly. Which is why when I said square root of 25, you told me 5. 5 times 5. When I asked the square root of 144, you said 12 because of 12 times 12. The square root of -4. If I said the answer was 2, that doesn't work because 2 times 2 is positive. If I said the square root of -4 is -2, I can't say that either because -2 times -2 is positive. When you take the square root of a negative, watch what happens on your calculator. I'm going to show you up here. When I take the square root of a negative number, the square root of -4, watch what happens. Yes, it does give you an error, but what type of error? What type of error? Non-real. Remember, in our notes, I said that if the discriminant were less than 0, you would have no what? Real solutions. Is there a square root in this formula? In the quadratic formula? Yeah, there's a square root. And what goes inside of that formula? What goes inside? What goes inside of that square root? What goes inside the square root? Oh no, people are afraid again. What is inside of that square root? Yes, it's a b squared minus 4ac, but what's that called? It's the discriminant. You're not allowed to take the square root of a negative until next week. Until next week. Because next week I'm going to show you this. Check this out. Next week I'm going to show you how to do something like this, where you can get an answer out of it. You look scared. It's so good. It's so funny. Oh, math. Why do you do these things to me? Click. There we go. Remind me next week, I can show you how the calculator has like a rudimentary system for speaking. It has like internal speakers where it gives like a robotic voice. Remind me next week. Back to this. Zooming back out. Because you guys have no idea what these calculators are even capable of. No idea. When I was in high school, me and my friend took like a month and we programmed a tic-tac-toe game from scratch. It was so good. Here we go. Give me a number. Single-digit number. Give me a single-digit number. Doesn't matter. Sure, I'll make it negative, though. I'll make it negative. I just didn't care. Example, x squared minus 7x. Let me make sure this works properly. I want to make sure that this works exactly the way that I want it to. Minus 18 equals 0. There we go. And the directions I'm going to give, I want to solve by quad formula. Now, here's the deal. I just gave you a problem on the board right now. I'm going to pick some off of the worksheet in a little bit. But I just gave you a problem right now that you could solve by factoring. You could solve this by factoring, but I'm not going to solve it by factoring. Instead, I'm going to solve it by the quad formula. When you are solving, notice, what does the equation equal? What does the equation equal? 0. Same thing as factoring. When you factored, you needed one side to equal 0. Same thing with the quad formula. You want it to work properly, it has to equal 0. If it is not equal to 0, you need to make it equal to 0. Identify the values of A, B, and C. Once you have it equal to 0, you can get that thing done. Here we got a 1, we got a -7, we got a -18. These numbers will work. They absolutely should work. So, first thing I'm going to do with the quad formula, I am going to calculate b squared minus 4ac separately from the rest of the problem. I'm going to calculate b squared minus 4ac separately from the rest of the problem. I may have said this before, and I will say it again. Parentheses will save your life. Parentheses will save your life. Be very careful. Let me show you why real quick. Look at my graphing calculator. Can you tell me what negative 7 squared is? What's negative 7 squared? What if I just said, hey, what's negative 7 squared? Just like randomly with no calculator. Yeah, exactly. Now I know why you asked about the parentheses. I know exactly why you asked about the parentheses, because yes, it does matter whether or not there are parentheses. It does. Makes a huge difference. Check this out. Look at the difference. I think that's exactly what you were thinking. Makes a huge difference. Parentheses will save your life. Anyway, back to this. Actually, I'm going to do the whole calculation now. So the b squared minus 4ac, I'm going to do negative 49 squared minus 4 times 1 times negative 18. Now, technically, I don't need the 1 there. I don't need the 1 there, but I'm going to put it there anyway. Click. Oh, that's a big number. What in the world? Oh, dude, why did I do? Yeah, why did I do that? Should be negative 7, right?
Yeah.
Dude, my brain is elsewhere right now. Haha, much better number. Much better number. Hey, do you know what's so special about 121? Yeah, it's 11 squared. Yeah. You should know your perfect squares, guys. Come on. Didn't they have you memorize them back in elementary school up to like 25? No? Ah, that's lame. 13 and 14 are easy. 13's 169, 14's 196. 15's 225. You should know that. Yeah. 256, 343, 512, 729. All right, cool. Back to this. Wait, no, it's not 729. No, it's not 729. I was way off on that one. 729 is 9 cubed. Okay, back to this. So here's the thing. This equals 121. Now, because it's positive, yes, 2 real answers. Because it's a perfect square, it's factorable, but I'm not going to worry about that. I'm not going to worry about the fact that it's factorable because I don't have to worry about it. It wants me to do the full quad formula. And at this point, I might as well go ahead with the full quad formula. So, negative b plus or minus the square root of the discriminant, the whole thing is over 2 times a. Look what I wrote. This is where you have to be extra careful. You have to be extra careful. I said verbally, I used the words negative b. Well, the b value was already negative 7. If I said negative b, it's really the negative of negative 7. Yes, I will simplify that in a minute. Did you ever learn back in the day, keep, change, or some junk like that? No? You did? Yeah. Keep, change, flip was like another thing for like dividing fractions and stuff, you know? But whatever. That becomes positive 7. It will. I already calculated the discriminant separately. I already calculated it above. Phenomenal. On the bottom, 2 times 1. Because it's 2 times a. Break it down piece by piece. So when I break it down piece by piece, I get something like this. 7 plus or minus 11, the whole thing is over 2. Now, I'm not done yet. Oh, I'm not done yet. Because if you can simplify, you should simplify. And oh, I can here. Now, at this point, yes, I've simplified the 7, I've simplified the square root of the discriminant, and I've simplified the bottom of the fraction. What's left is the plus or minus. You're going to get 2 answers. You're going to get one answer using the plus, and you're going to get one answer using the minus. It's really nice, actually.